Hi, good afternoon, everyone. Apologies for not being there in person, but I got hit by the weather, let's say, so it's better to stay away and not infect everyone else. And I really appreciate that the organizers are giving me the chance to actually still present a quick case study. And I just want to start by saying thank you very much for Engineer Walid on the insightful information. And I was hoping if I can actually jointly present the topic, because I mean he shared some of the insights that I was planning to share, but but that's um, that's absolutely fine. So if someone from the organizers can help me just to confirm that my screen is showing at full mode. Can someone please confirm that my screen is showing?
Yes, yes.
All right, perfect. So yeah, so I mean, thank you very much again. This is Hani from AESG, Associate Director of Sustainability. Our topic today is about carbon calculators and emissions and project emissions monitoring. And it links in a very nice way to the exercise that was presented by Engineer Walid Al Ghamdi. So my agenda today is very short, to be honest. I mean, I will be talking about like the current state of GHG emissions, and like, let's say, to understand the different components and the sources of carbon emissions in the property life cycle, and then like the use of carbon calculators in our decarbonization strategies, and finally how we can actually further utilize these carbon calculators for better business decision making. um so in general, and I guess it was just mentioned like a few minutes ago, the real estate sector accounts for around 40% of the global, let's say, greenhouse gases, and we I guess we listened to this like many times already today in different conversations. But I mean, it's really essential also to acknowledge that this is a key issue. Now, yes, it's not like the full like solution that we can have, because we still have some other emissions from the transportation and other sources. But I mean, as us leaders in the construction, we need to continue finding ways to actually like hit our targets, and we need to we need to cut these emissions at least by 50% in order for us actually to achieve our net zero targets. So cutting that to 50% means that we need to really think beyond the business as usual practices. Um, and I guess we all know about the climate change and the increase in temperature, and it's impacting also the real estate sector, and there will be the impact based on like increase of flooding, job losses, and other climate change in like, let's say, issues. The assets will have a devaluation, of course, and there will be also some kind of increase in operational cost based on increase in temperature and the use of the MEP systems. And overall, like for investment, this will not be any more attractive as long as the market is still like going forward with the business as the usual strategy. So we have to take a step back and actually like take advantage of the different solutions available around us, from digital tools, from materials, from methods of construction and design strategies to actually decarbonize the real estate sector. Um, and as mentioned by Engineer Walid, so I mean, we need to understand first of all that sources of carbon emissions at the service life of the built assets comes from different, like, let's say, sources throughout the full service. So I mean, and it's important for us to understand where we can influence and what we can control. Now, ideally, maybe for now, we know that we are not ready to actually decarbonize on many of these stages, let's say, but we can actually do small acts and more big acts on different stages, especially at the start, which, as Engineer Wade said, like from A1 to A4 and A5 and all the way to B1. And these stages were originally defined by ISO standards, let's say, and it's being like kind of commonly used to calculate the carbon emissions on an overall life cycle, to understand how to actually decarbonize and how to impact different staging of carbon generation by introducing different solutions into the process. So I don't want to like to spend a lot of time here on this one, because I guess we understood the whole concept. But I mean, for construction industry, and as we have in KSA many projects that are going into new developments right now, we need to really carefully think about the raw material and its transportation, and then how we are constructing it on site. And finally, like the utilization of the building itself and its operation is something also key for facility management teams to actually start thinking about ways to maintain efficiency or even to optimize it on yearly basis. So when it comes to the percentages, or when we try to actually like start analyzing, and I'm like just building the story of carbon before we jump into the digital tools, and it's important to understand, I mean, to break between embodied carbon and operational carbon. So first of all, the chart or the graphic on the right top end of the slide is from Letty, which is one of the UK sources which is driving the decarbonization like let's say movement in UK, and it's based on facts. I mean, we can conclude that 80% of the embodied carbon comes from like literally four main components, or three, which are the superstructure, substructure, and facade. So we can see also that MEP and interior finishes are the minority here. So concrete and steel, we all know that it contributes heavily. So what can we do? And we had different studies that we commissioned with different developers in UAE and KSA that we proved based on analysis and on carbon and cost point of view, we can actually decarbonize on the embodied level up to 30 or 35% with only like 4 to 7% of capital investment on the overall service life. And this is honestly something like it can be considered as a winning scenario, because I mean we can do significant movements on the real estate industry by just like introducing GGBS or other aspects, or for example replacing the steel to ultra high strength steel and other solutions. But I mean, again, what was discussed previously, it's important to understand what needs to be included in the assessments of carbon and what needs to be excluded. So from the overall components, and this is depending on the analysis or the targeted findings that we need. So most of the time when we do carbon analysis, we include the components that are presented to you here on the left side of the slide, and we exclude some of the specialty systems, including firefighting, water, fit out, and other aspects. Now, it's not necessarily that this is the rule, but this is like this is the approach to capture, let's say, 80 to 90% of the total carbon emissions from embodied and operational points of view. Just to kind of summarize in a quicker way, we did an exercise before on like trying to touch on different tools that are available in the market, and Engineer Walid mentioned, for example, one-click LCA. That is one of the mostly common tools that are utilized by the market to actually analyze embodied carbon. So in our exercise, and it depends also on the user target, let's say, or the requirements by the users to actually decide on which tool to be used. And here is something that we did previously for one of our clients. So we kind of assist based on criteria of ease of use, functionality, cost, reporting, and accuracy, to evaluate between 4 tools each, between embodied carbon and operational carbon. And on the embodied carbon point of view, we had one-click, OpenLCA, iStruct, and EC3. And we kind of concluded, again, as Engineer Reed said, that one-click LCA is really the most user-friendly tool. And it's also like it helps more in the accuracy because it's supported by a strong database of environmental product declaration, documentation of different materials that are authorized by auditors and reviewers. On the operational point of view, we also did the same exercise for Cove Tool, IAS, IFC Edge, Design Builder, and Cifera. So all of these tools are like, let's say, utilized to actually do some energy simulation exercises on like, let's say, certain timeline by introducing the design and the building system components and operational sequence to analyze how much energy is expected to be used, and we convert that energy to operational carbon. Now, in this specific exercise for that client, the main target was to find an easy to use tool to actually analyze the operational carbon. And while experts in the industry will agree all that IES standing out as the most accurate tool in terms of like its analysis and the functionality. And that the decision has been made based on the scoring that COF tool is scoring higher, because the purpose of the operational carbon analysis at that stage was to actually get an indication at early design decision, like from conceptual idea. And this is where, let's say, it's the benefit of actually having all of these tools. So we need to understand properly how we are utilizing these tools. And this is just like to give you a demonstration. Each tool will give you different analysis, will give you different, like let's say visualizations, components, and more details. But what we need to understand and what we need to be sure about is that what's the purpose of using these tools? And if it's for early design decision, then it means we need something that is more streamlined. We need something that can help us in certain assumptions. If it's more like to the granular level, then we need something that will look at the nitty-gritty of the building, let's say, systems and operation and sequence, so that we can define each space and each, like, let's say, square meter in the building in the right way. And just to wrap it up quickly, what we can do beyond this is actually to develop something to develop something that is bespoke for business decision. And this is something, for example, that we do in-house, where we develop, like, let's say, a digital tool that can link to such like, let's say, publicly available tools, to like, let's say, to link on and gather data and then report it on a portfolio level. So what can be done to help the business decision is that to set up a carbon monitoring tool that will analyze different, let's say, assets on the portfolio level based on consumption, based on design characteristics, and then to analyze these from embodied and operational carbon point of view, and then to report it on a dashboard, for example, using Power BI, and then to kind of help in, like, let's say, the management team to actually understand the trend, comparing emissions between projects, especially when we have the same, like, let's say, asset typology, but in different regions, and maybe view more of the carbon details at the project level, or maybe at a system level. And this would help actually corporates and big developers to understand how they can influence their projects to actually start becoming more efficient, and to help us all together in decarbonizing the industry. I know that I'm running out of time, so I will just summarize this slide in few words. So another use of the tools is that actually when we develop a decarbonization strategy, we make sure that one of the key first activities is to actually quantify the carbon footprint. And it's also like here where we try to utilize these tools to help us in understanding that the direct carbon emissions that we have from embodied point of view and operational point of view. And then we take these findings to actually help us in setting the target, for example, based on science-based targets. And then we start implementing certain reduction measures, and finally reporting based on international standards. And sorry if I took more time, and that's it from me. Thank you.
And